Good evening, everyone. I'm Molly, and you're watching the Astro Imaging channel, and we're happy to have you here. Tonight we have Craig Stocks with us, who's going to talk about how he's built the Utah Desert Remote Observatory and observatories, and how he's done that, how decisions that they made, things like that. Craig is a retired mechanical engineer who's been doing photography and astrophotography since the 1970s, very into photography. And so he's going to go through that for us tonight. Before we get to that, a couple of administrative notes. Our upcoming shows, next week we've got Nico Carver on, also talking about building an observatory, but this one is one for your backyard, so you can get away with a little bit more when you can go out and fix stuff as opposed to when it's so remote. The following Sunday is our TAIC workshop with Eric Cole's M101 data. Today is the last day to submit your M101 image, and then we'll choose some folks to come on and talk about how they've processed that image. So we'll be looking forward to that show, which is, I don't have the date for that handy, but it's upcoming. And let's see. Oh no, that is that show. The week after next, when the people will be on. Okay. Yeah, so the due date for that is today, if you haven't gotten it in yet, for the show that's in 2 weeks. Yeah, that's all the notes that I had, actually. So, all right, Craig, take it away.
Okay. Okay, so you should be seeing my screen now.
Yeah, looks good.
Okay, then let's jump right in. So as Molly said, I'm going to be talking about building a remote observatory in the Utah desert. And we are a commercial entity, so I hope this doesn't sound like an advertisement. But I will say our goal is to provide the best customer service experience in the industry. We really have three main business models. Peer rental for remote operation is our main business, but we also do a little bit of by the hour imaging systems rental. So you could, rent a system, rent some time on a system for a particular target. We do have one complete system that you can rent by the month. And of course, everything is done remotely over the internet. Peer rentals, pretty standard model. You rent by the month with a 1-year lease. We have 2 roll-off observatory buildings. We provide the concrete foundation power with an automated backup generator, high-speed internet, roof control, and so forth. So, pretty standard business. This is a family business. We actually started in 2021, so we're about 3 years old now. And in terms of our roles, my wife is really the business and finance person. She kind of takes care of all the stuff that nobody else wants to do. Our son is kind of the facilities, grounds, and electrical. In his day job, he's the underground foreman for a large electrical contractor here in St. George, Utah. Our daughter and son-in-law actually live on the property, so they're the kind of the full-time on-site caretakers. Our daughter basically is in charge of observatory operations, and our son-in-law is the lead telescope technician and also fabricator. And they have 3 sons who pitch in when needed, and that does come up occasionally. So to start, the first thing we had to find was a location. And of course, paramount is to find a location with a dark sky, but we also needed access to high-speed internet and power and water. And if you're familiar with water rights in the Western United States, you can't just go poke a well any place you want. You have to actually have rights to the water as well as owning the land. So, there was a lot of things that we had to consider in our search, and we looked in Utah, Nevada, Arizona, even a little bit of California. And eventually we found just the right spot about 60 miles north of St. George that really fit all the criteria. So starting out, this is what the area looked like before we did any construction. And we have 120 acres. So what you're looking at is, I guess, most of what you see here is our land. And this white spot at the across the bottom is a wash. And then on the other side of the wash is a little bit more of the brush like this, and then the county road that we're attached to. The first thing we had to do was build our own road out onto the property. And along with this road, which is about a half-mile long, we also had to bury utilities. So we buried water, power, and then the internet got buried along there also. For power, we had to put in a transformer here, and then there's another transformer down here. Next, we built a shop building, and that's over here on the left, and that's used for various fabrication needs, equipment storage, things like that. Next, we put the building at the back. This is another shop building, and then this is the home for the caretakers. So our daughter and son-in-law live back here, which is in about the middle of our property, very close to the center. Eventually, we got around to building the first observatory, which is right here. That was completed in late 2022. In early 2023, we started the planning for a second observatory, which wound up right next to it. So, overall, and here's a flyover courtesy of Matt Dietrich, which of course is not playing. There we go. So this is what it looks like as of about a month or month and a half ago. But first things first, starting out, we had 120 acres of almost nothing. We had a lot of work to do up front. And a lot of this we explored during our due diligence period when we made the offer on the land. We had to talk to the county zoning people to make sure that we could actually build a remote observatory business out there. The land was zoned for agricultural, and there's a whole long list of permitted activities on land that has an agricultural zoning. Remote observatory operation is not one of the kind of automatic recognized activities. So we had to get a conditional use permit, and that had to be presented before the county zoning commission to approve our use of the land. And then we also spent quite a bit of time exploring the water rights to make sure that we really had good water rights that were coming with the land. There was some question about it, but everything turned out okay. The land did have a well, but it was non-functional. And then we had to form the LLC, get the business licenses, do all those kinds of things. This is the plan. It's one of the pieces that was used for our conditional use permit. So on the right-hand side, this is the county road, which is a gravel road. Surprisingly, that has high-speed fiber optic internet running down it. That was one of our big surprises out there. Turned out the telephone company's old copper wires needed to be replaced, and they found out it was going to be cheaper to replace their copper wiring with fiber optic. So that's how we wound up with high-speed internet out in the middle of nowhere. This is the gravel road that we put in. Here's the shop building. Here's the observatories. Here's the caretakers building. And up front, there was an existing structure, and that's where the well and the power came onto the property. The existing structure did need a little bit of work. It was in pretty rough shape. So the first thing we had to do was dispose of that. That wound up getting hauled away in 3 big roll-off dumpsters. And when we were first starting out, we didn't have any equipment yet. So our son, through the company that he works for, he was able to borrow equipment for the weekend. So he borrowed this little Bobcat excavator to do the demolition. That all got loaded into 3 roll-off dumpsters, and we used that space then to create a little RV pad, which we still have. So if we use that during the nicer parts of the year. If somebody's coming out to install a telescope and they have an RV, they could park up there during the installation. But we decided early on that it would be a good idea to build a prototype observatory, since none of us had ever built an observatory before. So we decided on building a small 10-foot by 12-foot prototype, using as much as we could the same kinds of processes that we would use for the larger observatories. So we were going to use the Quonset hut design, and actually from the same Steelmaster company. It would house just a single pier, but like I said, build it the same as the full-size observatory, and that would let us test building methods and control systems and so forth. And in fact, we still use it as a test bed. If we're going to change something in our control scheme, we'll test it there first. And this building rides on two 24-foot long steel I-beams. So first thing we did was, you have to put the pier in the ground first and then build the observatory around it. So first thing we did was dig a hole and fill it with concrete. And that took about 1.5 yards to 2 yards of concrete. And then we put some rebar in and set a sonotube in the wet concrete. And then once that cured, we came back a week later and filled the sonotube with concrete. So we were ready then to start laying out the building. The first rail, and the rail was all fabricated. We didn't have the shop yet, so that was actually fabricated in our garage. And here it's sitting on 4x4 wooden posts that are set in concrete. We have a frost depth of about 30 inches, so everything's set, 30 to 36 inches deep. The first rail's fairly easy to put in because all you have to do is get it the right distance from the pier. And generally, we wanted it pointed east-west. The second rail is a lot more difficult because it has to be the same height as the first one. It has to be level, and it has to be pointed in exactly the same direction. So there's a lot more things that go into setting the second rail compared to the first rail. Once we got the rails in, here you can see the C channel that the building sits in. And it's a little hard to see, but we've got hoist trolleys that would typically be used to hang a hoist from an I-beam like this. We have them upside down, and we fabricated brackets to hold them on the bottom of this C channel, which is about 7.5 inches wide. And then there's rollers inside the trolley, and then there's also a center roller here that just rides on the I-beam. And then you erect the building on these two C channels. So here we are, kind of fumbling our way through getting the, this is only 6 arches that had to go into this system. That each arch is about 2 feet wide, so a 12-foot long building takes 6 arches. We got the first one up fairly easily, but by itself, they're extremely wobbly, so you need to hurry and get the second one up. And we were using the excavator and a strap to hoist the arch into position, which worked to get it in position, but we were kind of at the limit of the reach of the excavator, and having the strap in there when the arches overlap turned out to be really kind of an issue. So it got us through here, but it wasn't a very good long-term solution. But once you get the second one up, you just keep going, 3rd, 4th, 5th, and eventually we got all 6 up. And notice that took us basically all day to put those 6 arches up. But we learned a lot in the process. Then we framed up the back wall, and this is framed more or less like a pole barn. There's a 2x8 beam at the bottom, a center 2x4 that goes up to the top, and then horizontal 2x4s that we can attach the steel siding to. Then we put a floor inside. And so here's just a quick time lapse of my wife and I framing up the floor and putting down the floorboard. You can see the concrete riser in the middle. And once that was in, then we built the half wall that goes around the floor, and then the front wall, which is stationary. So the back wall moves with the observatory, the front wall is stationary. So to keep it simple, the side walls are just 4 feet high. So you use a piece of 4x8. We used a lot of OSB board. in the horizontal dimension. And when you get done, that's what it looks like. Obviously, there are the rails. This is the opener. It's a gate opener. And then we use it with a sprocket drive. So we have a chain that is attached to the front of the observatory, and then this extension comes out the back, and then the other end of the chain is attached here. And then the opener basically just pulls the building back and forth. And you get quite a bit of rigidity and resistance to racking in a building like this, just naturally. But we did put a cross brace in, and that really keeps everything square. That's what it looks like from the front. So we've got a door. We have a concrete porch here now that wasn't in it when I took the picture. So that's how you get in. And then when you open it, it just rolls off to the east. And there it is. That we learned a lot building this first little observatory. And we operated it for several months with it connected to the weather systems and so forth, just like we would in the full-size observatories to get comfortable with how everything works. So with that, it was time to start thinking about the next observatory. So do we have any questions so far?
Not so far, Craig.
Okay.
Unless, Alex, you do have a question?
I don't see any questions. We've been having some discussions about when one needs an observatory, depending on the type of equipment they've got and stuff, but it's not really related to building an outfit like you've got.
Okay. So the design concept for our first main observatory, we were going to have 18 locations. So, at most it would hold 18 telescopes. We plan to use independent concrete piers that would be isolated from the floor. And in terms of terminology, just to avoid confusing ourselves, because we have piers that we attach to piers. So we call the concrete a riser that comes up, and then we attach a steel pier to that concrete riser. We have a crawl space under the floor, which is where all the wiring would go. And then we planned an attached office, which would function as a warm room. That's where the computers would live. And also we wanted to have a restroom. This was our designer's rendering showing the office on the west end. So in this case, much like the prototype, the west wall is stationary, and then the building rolls off to the east. And that preserves the north-south and especially view to the south. This is a rendering that our oldest grandson, who's a mechanical engineering student, he'll be graduating in May. He got the task of putting together the layout for all of the telescope locations, assuming that we wanted a 6 foot to 8 foot center to center separation between the locations, and maximizing the space and allowing for a pony wall down the center to support the floor. But beyond that, the biggest consideration was in the floor joist layout. And where that becomes important, we have 24-inch concrete risers that come up through floor joists that are 16 inches on center. And these are 2x12 joists. So it's obvious you're going to have to box around that 24-inch riser where you split a floor joist. But we have to be careful that we don't wind up with a situation where we're splitting two joists. Because if you split two joists, now you have to sister these outer joists because they're carrying more load than in the simple situation. And also, once you use this joist, for instance, to support a boxed in riser, you can't use it for another one. So you have to go to another joist in order to go in the other direction. So with all those considerations, this was, we had to avoid this. The spacing becomes very critical. We had our official groundbreaking April 30th, 2022. So real close to 2 years ago was when we really started building the first observatory, which we call the SAGE Observatory. And like before, the first thing we had to do was dig a bunch of holes to fill with concrete to create all of the foundations for the telescopes. And the challenge here is you're out in the middle of a field with no point of reference other than a compass to look at north, south, east, west, but there's nothing else to draw measurements from. So we went back to our draftsman and had him put together this diagram that showed the floor joist layout and the location for each riser. And then he placed 2 reference points 50 feet apart and 12 feet to the north along this baseline. And then he gave us a dimension, basically a triangulation from those 2 pins to the center of each one of the risers. And then in the field, we could drive 2 pins in the ground and pull 2 tape measures and go to the exact dimension, and that would be the center of that pier. And that's how we laid out those holes that we're eventually going to fill with concrete and put in risers and then build a building around and hope everything lines up. So once we got the holes dug, we put in, I don't know how many truckloads of concrete, first to fill the foundation and then to fill the sonotubes. And these are quite a bit taller, so we could only get about either 6 holes or 6 risers out of 1 truck of cement. And as luck would have it, after we filled the first 6 holes, the batch plant where we get our concrete had a breakdown, and they were down for about a month waiting for a part. And if you weren't a big contractor building a hospital or something, you didn't get concrete. So for about a month or month and a half, we didn't get concrete, so we were just stuck. Eventually things started flowing again, and we were able to get the rest of the holes and the rest of the sonotubes filled with concrete. And eventually we wound up with all 18 risers, and then we had to excavate around them to pour the footing and the stem wall that was going to support the building. And if you look off in the distance, here's that wash. And then in the distance, you can see the couple of RVs and the little prototype observatory on the other side of the wash. So this isn't, because of the shadows, this looks deeper than it actually is. But again, it has to wind up at least 30 inches below grade. So we did have a contractor come out to do the concrete forming and pour. So that's one of the things that we outsourced. So here we've got most of the forms up. There he is pouring the concrete. So you can get a feeling for the height of the stem wall. This is the foundation. One of the things we had to do, besides digging out the space to put in the forms, we actually had to dig a foot below that and then do what's called over excavating or over-Xing, where you dig a foot down deeper than you need, and then you use water and soil and compact it as you go with a jumping jack to bring it back up to the level that you want. And then the geotechnical service has to come out and test the compaction to make sure it's good before the county signs off and you can pour concrete. So now the concrete's in, forms are stripped, and we're starting to backfill and compact around the building. And there's a compaction requirement around the outside of the building as well. Here you can see we've got a water hydrant in now. And we've got plumbing kind of roughed in this corner for the restroom. And you can also see the spot footing down the center here, and then also through the observatory. And that's where the pony wall goes to help support the floor joists. Once we got all the backfilling done, we put down pea gravel in what was going to become the crawl space so that it'd be a little more comfortable to crawl around. And now you can see all of the risers, and eventually the floor level is going to be right below the top of that riser. Then we started putting in the support columns for the rails where the building will open. And so again, that was another layout challenge. So here they are filled with concrete. This is looking the other direction. And you can see a couple things interesting here. The J bolts that will attach the sill plate and the band joist for the floor. But also you can see these steel plates. These are weld plates that we set in the wet concrete. They have rebar welded to the bottom. And that's what we're going to attach the rails to when the building opens. Now, even though these are weld plates, we don't actually weld the track all the way along because we've got about 90 feet of rail, and the expansion, thermal expansion, would possibly create problems. So it's actually only welded in the center, and then it's clipped everywhere else to allow the rail to expand and contract if it wants to. Now here's our son-in-law, Steve. He's the fabricator. He's putting down the rail, and you can see in this one, we have an inverted angle iron on top, which creates a V, and then we use V-notch rollers for the building to actually ride on. So it took him a few days to get those all welded in, and of course every beam was bent a little bit, so everything had to be coaxed into position to be straight, level, and true. And the other challenge is we had to use the sight level to find the highest point out of all of the weld plates, and then shim everything else up to that level so that everything winds up being level. Eventually, we were able to slide the C channel on. So here you can see quite a bit beefier roller than what you saw in the prototype. And then this is the bracket that holds the trolley that captures it onto the I-beam so the building can't come off. There's a better view of that C channel. We did have a framing crew come out and do the basic framing. And while they were doing that, we were doing other stuff. And one of the things we did after they got the floor joists in, we asked them to take a day off so that we could pull all the wires through. So we ran all the power and Ethernet cables from the office out to each one of the risers to the telescope location. So that was be ready to go. And then they came back and put the floor down. Surprisingly, the whole building comes on one pallet. So this is the entire Quonset hut for the observatory with everything except for the C channels and a little bit of trim, and there's a couple buckets of nuts and bolts. I mentioned that the excavator and the strap didn't work real well. So for this one, we built this cradle that we could put on the forks of the skid steer, and we had to build it fairly high because the skid steer is at ground level and the building is about 1.5 feet above ground level. So you have to make up that distance plus get up 12 feet in the air in order to set the arch in place. And this was tall enough to do that. So this was how we raised all of the arches up into position. So before we started, a couple things to note here. One, we pre-assembled the top part of the arch. So this little V shape in the background, that's actually 3 pieces. There's a little crown piece and then 2 straight pieces. So those were pre-assembled ahead of time, so we could just set them up in the cradle. And also notice we didn't put all the rail in because it just gets in the way when you're walking back and forth. But basically then we would just assemble the building over the end of the floor and just keep rolling it forward as we went. So here you can see once we get the first 3 pieces in the cradle, we raise it up and we attach these 2 arched side panels. That's the arch right here. And then we've already set the vertical panels into the C channel. So when we're ready to fly it into position, we just raise it up with the skid steer, bring it up, set it in position, and start using what's called a spud wrench, which is like a punch that you can put through the holes to line everything up and start putting in bolts. Again, our son was able to borrow a bucket truck from work, so he could help out with a lot of the high work. And between ladders and scaffolds in the bucket truck, we were able to put this building up 22 arches in 2 days. So by the end, we felt like we were really flying along as we kind of figured out our roles and positions and hit our pace. Just a view from the inside looking out. This is the opener for the Sage Observatory. So you can see how it pulls the chain through the sprockets here. And another view of this is a 6-inch steel roller bearing V roller, and then the trolleys riding into the brackets. And the trolleys are mostly just hanging loose. Unless the building raises up, there's no tension on those. We framed the back wall. This is a double 2x8 beam, and then quite a bit more framing than you saw on the first observatory, since this is 24 feet wide. So here's Steve, our son-in-law, and I putting up the steel end cap after we've already framed it. And you can't really see it in the picture, but every point where the I-beam connects, or sorry, where the 2x4 connects to the building, there's basically a unique or a custom steel bracket that connects that 2x4 to the steel building. And then we finished the office on the inside, electrical, plumbing, insulation, paint. Our daughter did a lot of paint, and we went through a lot of caulking. We chose to do everything in just painted OSB rather than trying to use drywall, and then just caulked all of the seams. So we went through several cases of caulking. I mentioned that we had a bathroom. Well, with a bathroom, you also need a septic. And again, you don't just put in a septic, you have to get a geotechnical survey. They design the septic. You get a permit based on the design. You put in the septic, the county comes out and inspects it. In this one, we had an additional challenge. As you backfill around the tank, you fill it with water. And when Steve came back, I think a day or two later, to put the risers on to bring this up to grade level, he noticed the tank was empty, so it was leaking. So we had to cut the pipes, dig it out, pull the tank out, take it back to Home Depot, exchange it for one that didn't leak, bring it back out, and now we had to set it in to match the pipes, where before we set the tank and then ran the pipes to match the tank. So it was a little bit more of a challenge, but we got it done. And eventually, we wound up with an observatory that looks like that, with steel siding, steel roof. This is the half wall. We've got an automatic backup generator that runs off of a 500-gallon propane tank that is over by the shop. This is the automatic switch gear for the backup generator, and then the internet comes in this corner also. Side view, this is a little later after we've got some telescopes in, but one thing it shows is this cargo bay where we have double doors that we can open in the half wall that surrounds the telescope floor, and that lets us bring crates and heavy boxes and stuff in, and set it in with the forks on the skid steer rather than trying to bring stuff through the office or lift it over the wall. And you can also see here how the building opens about 10 feet beyond fully open. Now you can see the door here in the center that goes into the office, and the office door is also in the center. And so one of the fun things that does on the Equinox, you can stand at the back and sight through both of those open doors and see the setting sun. We have in the office, we also have storage for each customer for things like spare cables, lens caps, whatever things that aren't attached to the telescope that need to be left there. So everybody has a little storage spot. The first customer that we put in was, well, actually our second customer
Craig?
was iTelescope. Yeah.
Since you kind of got to the end of the construction, there are a couple of questions.
Sure.
Okay, so where did you get the idea to build that type of observatory with all those details and dimensions? Let's come from someplace.
Probably the basic idea came from looking at pictures of Deep Sky West's observatory, and then from looking at their picture on the website, and was, oh, that looks like a good idea, and then we've had to figure out the rest.
And why did you choose the Utah Desert? I guess you kind of covered that earlier, but
Well, partly because we live here, and partly, we found the land that had Bortle 2 sky. The reading, it's officially a Bortle 2. If you look at our readings night to night, they can vary quite a bit. So we'll have readings in the 1s and readings in the 3s. But on the map, it's a Bortle 2.
so you're seeing, what is your average seeing?
It's in the, I don't know if you can compare it to readings from other observatories because there's a lot of ground effects that, depending on how high your seeing monitor is located. But our seeing monitor generally reads in the 2s, 2 arc seconds, sometimes below. It's a good relative measure. I don't know if it's a good absolute measure to compare to another observatory's seeing monitor.
Mhm.
I don't know that it's not, but I don't know that it is. But
Edward asked about the speed of your network.
it's a full duplex gigabit, and then that's connected internally. We have a 10 gigabit fiber backbone that connects all of the switches, and then eventually to Cat 6, gigabit cable that goes to each pier.
And how do you handle, in the weather, the open and closing of the roof?
That's all automated, and I'll touch on some of that later. But it's automated through the weather system and the roof system.
And don't you have monsoon seasons there as they do in Arizona or not?
We do. It didn't really affect us much last year. Even if we have clouds and rain during the day, we've noticed 2 things. We're in a bit of a rain shadow, a local rain shadow. And I don't know if you noticed in some of those construction pictures, but as we go through more of them, pay attention. You'll see a lot of rain off in the distance and sunshine where we are. It's not unusual. We're completely surrounded by mountains, and it's not unusual to see rain in every direction and have blue sky overhead and not get a drop of rain. And generally, especially during the summer, the clouds that do build during the day just kind of evaporate and disappear at sunset.
In your first couple of years, how many clear nights do you have a year?
We average imaging about 78% of the nights. And in terms of hours, it's between 1,800 and 1,900 imaging hours per year.
And you have this straight piers. You don't have any accommodation for heavy telescopes and offset piers, right?
Yeah. We've got L600s on equatorial wedges in the new observatory.
And do they have offset piers, or are they held on a wedge?
From talking to Planewave, we were told we didn't need them, but it's well anchored into a heavy piece of concrete, so we don't need an offset pier to balance. It's because it's on a heavy post-tensioned concrete slab. So it's anchored to the slab as well as it would be anchored to a offset pier.
Is there a light dome in any direction that you have?
There's a little bit to the east and a little bit to the south, but I don't have any trouble imaging down to 20 degrees to the south.
How far away is Vegas?
It's about 120 miles as the crow flies. It's about a 3-hour drive.
How do you deal with keeping like rodents and insects and stuff out with that design?
You're at the mercy of insects, and the only real insects that we have found are moths, and moths can get into just about anything. They've even gotten inside some of the mounts, so we've started putting screens on the mounts. We haven't had any rodents in the observatory, and I don't know if that's because of the clear space around it or if we've just got them very well sealed, but we haven't had any rodents in the office or the observatory.
How long you are out in the desert, how long does it take to cool down what's your opening schedule like?
We usually open 45 minutes or so before astronomical dark, sometimes earlier if people want to shoot sky flats. During the summer, and we do get some hot days up there, we cool the observatories with water. So we've got a sprinkler, like a garden sprinkler, on a timer that we can run for like 2 minutes every 10 minutes. We can control, so we're not putting any more water out than we need, but a little bit of water on the roof and then the evaporative cooling, and we can keep it in the 90s inside, and then typically it would be, you know, maybe 75 at opening time at dark.
And you just answered the last question without being asked. I think we're all
Okay.
set. Any more questions out there? I think we're all set.
All right, you can go for it.
Okay. So as I mentioned, our first big customer was iTelescope. We moved 8 telescopes from another location. So we went down, retrieved them, brought them here, and did the installation. And it was, I think, less than a week from starting disassembly to having everything installed and polar aligned. So this is just a quick time lapse showing the installation. So we went from a pretty empty observatory to a pretty full observatory in a week. This is just what you would see walking from the office into the observatory. A little stroll around. There's the cargo bay. So this is a view from the camera right above the door going into the observatory, looking back to the west at sunset. And as you can see, the observatory is starting to look pretty full, and it's quite a bit more full now than it was when I took this picture. So that led us to building the second observatory, which we called the Primrose Observatory. And the first thing you'll notice is that it has 2 roofs. So the design differences, we found the individual piers, found a couple things. One, they really limited our flexibility, especially with larger telescopes, and we were beginning to attract larger systems. We wanted more space, so we actually wanted it to be bigger. So this one was designed to around 25 by 60 feet long, which means now the roof would have been getting quite large. So we decided to go for a double roof that opens from the middle out, and that completely eliminates any kind of a fixed end wall. And after a lot of conversation with other people, we decided to go for the concrete slab floor rather than the individual piers, partly for the flexibilities that we can put a scope almost anywhere. But also, I think I'm finding that it's far less prone to vibration and movement than the individual piers. And the reason I say that, individual piers are isolated from the floor, but there's nobody out there at night. In fact, we don't allow anybody in the observatory after astronomical dark. So there's nobody plodding around out there at night anyway. But the single slab, 9.5 inches thick, attached to footings that go 3 feet down, there's what, 200 and some thousand pounds of concrete there. It doesn't move easily, where the individual piers are isolated from the floor, but they're not isolated from the ground. So any vibration in the ground gets transmitted through those individual piers anyway. So I don't think we were really getting what we thought we were getting with isolated individual piers. Now when we put this plan together, our plan was then to put a false floor over the concrete slab. I don't know if we're going to or not. So here we are. Here's Steve, our son-in-law, setting one of the weld plates. So this is kind of picked up already in progress. So we've already dug the 30-inch or 3-foot footing all the way around. formed it up, and this is the first pour that pours the foundation, and then this top piece that the rails are going to ride on. So he's setting the weld plates in for the rails. Once that was in, and you can see there's a little bit of an offset here. This is where the buildings, there's a smaller building that goes inside the larger building. Now it's formed for the floor. So we've got 2x8s. And when you consider the elevation of the gravel in the center, we went up with about a 9.5-inch thick slab. And we went a step further and decided to put in post-tension cables. So there's cables on about 30-inch centers running in both directions. And after the concrete was poured, they came out the first day and they tensioned the cables to about 15,000 pounds. And then they came back about a week later and tensioned them to around 32,000 pounds. So even if it cracks, it's not going anywhere. We started, I think it's like 3:30 in the morning was when the first truck came. It was they started way too early for me. There's our concrete contractor floating the floor, and you can see the Sage Observatory in the background. That septic is right in between the two buildings for orientation. Then we needed to bring the I-beams over, and Steve did most of the fabrication in the shop as far as welding the angle iron onto the beam. It was just a lot easier to do the fabrication in the shop rather than out in the field. Set the I-beam in position, and then he started welding it down. Here we are. The weekend before the main event, we pre-assembled those top arches. So here's our son, Chris, and his son, Cohen, pre-assembling one. And it's hard to tell, but what he's using is called a spud wrench. It's like a punch that you could put in through the holes and then move it around as a lever to line up the holes and drop in bolts and put nuts on. So here we are getting ready for the day of to start construction. So we've got the rail stubbed in. There's the C-channel sitting in position. Interestingly, each one of those C-channels is about 12 feet long, 10 to 12 feet long, and they are not interchangeable. Everyone is designed to go in a certain spot. So part of Steve's challenge was figuring out exactly how all of the C-channels line up, and then fabricating the brackets and attaching the rollers and all the trolley brackets. So those are all ready to go. Again, first arch is in position, and then it's pretty wobbly. So we had a couple of grandkids hold it in position while we got the second one up. Pre-assembling on the cradle. So good shot that shows the in position on the cradle and the crew inside. We got a lot better at putting up buildings. It took us kind of all day to put up that first little 10 by 12 6-arch observatory. The second one was 22 arches. That took us 2 days to put up. This one was 31 arches, I believe, and we got it up in a day and a half. So we started at 7 a.m. on Saturday, and by noon Sunday we were done. So there it is, Sunday afternoon. Our son's just kind of finishing up putting the trim pieces on the end. And again, the bucket truck was very handy for that. So then we had to frame in the end walls. In this case, you've got the double 2x8 beam, and now we've got a steel plate in between to create a flitch beam, so it's even stronger. And then here you can see we're framing in the half wall that goes around. There's the framing for the west end, and this is where the entry door is to get in, and then there's a little entry vestibule that's closed at night. And eventually you'll see that we'll put a porch out here. There's a closer view of the V-notch roller and the trolley bracket. And you can see that we do get snow and ice. So we actually have heat traces in the track running through the angle iron. So the rails are actually heated so that they don't build up any snow or ice. Then one of the last things we did was Steve got up on the top with a hose and we sprayed everything down and checked for leaks and tightened or replaced any nuts and bolts that were leaking. And there's a lot of nuts and bolts. So there it is, all done. Here you can see the porch, and the building goes over top of the porch. So the porch stays put and the building moves. There's kind of a step here. You can step over the rail and then go in through the door. And if the building's open, you just go up on the porch and go in through the vestibule. There's a beauty shot looking west at sunset. And here you can see how the east building kind of goes inside the west building. And my favorite thing to do is to watch the buildings open. So here's a time lapse. Actual time is about a minute for both buildings each building to open. And there you can see how it opened beyond fully open. This is what it looks like inside. As of a month or so ago, we've got another scope back here in the corner, L500 with a CDK17. That and the L600 with a 24 are both on equatorial wedges. The 4 scopes here are part of the Polish Space Agency. And then there's a CDK20 back here on an old plane wave Ascension mount. You can see the joint between the 2 buildings, and we spent a lot of time thinking about how to seal that. And I mentioned that the buildings overlap, and beyond overlapping, we also have a double set of seals. On the outside building, you can see some plastic sheeting. Here's a closer view. So we've got this plastic sheeting hanging down into the fold, and then there's brush seals on both buildings that seal on the inside. So if you think about that schematically, here's the outer building and the kind of that corrugated shape. The inner building goes inside about 18 inches. And then we have 2 sets of brush seals set on each building, and they almost come together. You don't want them to get tangled up, but they just kind of barely touch each other to seal. And then we have that plastic curtain on the outside. And we have not got any rain, snow, wind. When Steve was up on the roof with the hose, he even sprayed water directly on that, and nothing comes through. So it seals even better than we expected it to. Yeah, there's just a lot of other stuff that goes on inside the observatory. We've got the server cabinet in one corner with the 2 computers. Each roof has its own roof opener, and each opener needs its own computer. We've got a Wi-Fi hotspot, and then we've also got a lot of just material handling equipment, rolling tool chest with the tools that you might need for working on a telescope, gantry hoist, and a pallet jack for moving heavy crates around. There's a lot of hidden tasks. Customer service is important to us. Customer communication. The computer network is extremely important. Weather and roof controls are obviously an issue. And then there's just always things with the grounds and buildings and maintenance. So one of the things we do is install the systems for people. This was installing a CDK24 on a L600 mount. So just a quick time lapse. That was the night before. Unloading the equipment, bringing it in through the cargo bay, moving things into position. There's the scope. Ta-da would be appropriate at that point. And then using the hoist to get things in position, the His pier and wedge were already attached. There's the mounts attached. We're setting the scope in position, get everything installed, balanced, and wired up and ready to tune. And there it is running. And we have a service ticket system on our website, so customers can go to the contact page and submit a service request, and then they can track their service request. We get notified anytime a service ticket comes in, and then the customer can also track the status, and we can communicate back and forth through the ticket system. We also have a Discord channel or Discord server. And one of the things we do is every night around a couple hours before sunset, late afternoon, early evening, depending on the time of year, we'll just put out a little Discord notice of the outlook for the night. Is it going to be clear? Is it going to be cloudy? So you know what to expect for the night. There was a question earlier. It's a full duplex gigabit fiber to the observatory. And currently our usage peaks at about 20% of capacity. And we can easily double the service if we need to. We could go more than that, but we can easily double. And then internally, we have a 10 gigabit fiber backbone connecting all of our switches. It's all commercial grade equipment with Cat6 cable going from the switches to the scopes to maintain that full gigabit speed all the way to the telescope. We run auto ping monitors that will alert us if anything goes out on the network. And we also provide a shared network drive, so the customers have access to weather system data and the roof status to know if the roof is open or closed. We have actually two weather systems, a primary and a backup. The four roof systems then monitor the weather system data and automatically decide whether to open and close based on obviously time of day, but also clouds, wind, humidity, moisture, daylight, those kinds of things. And we can control those parameters. And then each telescope monitors the roof status file for their roof system, so they know if their roof is open or closed. And basically that's used like a safety monitor. So when the roof is open, your system knows to go start imaging. If the roof closes for some reason, then the systems generally just suspend operations and idle until the roof reopens, and then they will restart. And lately I've been playing around with an artificial intelligence tool, little program I put together to evaluate the all sky camera to judge if it's clear, partly cloudy, or cloudy. And after about 4 iterations on the model, we've got it. Actually, I've got it working fairly well now. Well enough that I've got for reference purposes, we've got that on our website now. So this was earlier this evening, showing the all sky camera, and the sky condition was clear. We've got building locks. In case we have a windstorm, we can actually lock the buildings shut. We don't normally lock them. They don't normally move very easily, but with enough wind, it's conceivable they could move. So we have remote controlled locks that we can lock the building. Generally, we make the decision to lock the building, but if the roof does open, it will unlock the building before it opens. And then we've got a video camera at each lock position so we can visually confirm that the building is locked or unlocked. So rounds and maintenance is something that is just kind of never ending. There's lots and lots and lots of gravel out here that we've had to put in. This is a view looking down the building. You can see we started getting a little bit nicer with we're now putting down a topper on top of the road base, which is a lot cleaner. So we don't track dirt in and out. So here's our son with the skid steer putting down some of that topper on top of the road base, and then teaching his son how to use a plate compactor to pack it down. But Cohen's favorite job is actually anytime we have something that needs done in the crawl space, since he's the smallest and he can squeeze through the pony wall the easiest, he's usually the one that gets to go down in the crawl space and pull wires if something needs done. So here's an aerial view of both buildings opening. And again, this is a time lapse. Its actual time would be about 1.5 minutes. But I just never get tired of watching the buildings open and close. So I get a lot of questions from people, not a lot, but people say, I'm thinking about getting a Quonset hut. Do we have any plans, or how do you do it? We don't have a lot of detailed plans. What we had was a lot of skills and equipment to do construction. We've got earth moving equipment and experience using it. We've got a steel fabrication shop, and our son-in-law in particular has years of experience doing fabrication. Our county building department has been pleasant to work with, I'll say. They help us meet the requirements without putting onerous requirements on top of us. Inspections are very simple, and they don't really require a lot of, other than the foundation. They want a detailed foundation design signed off by a structural engineer. Other than that, the whole observatory was kind of installed per manufacturer's instructions. No details. When we need a bracket or something made, we just go make it. And the other big advantage was the availability of high-speed fiber optic internet out in the middle of nowhere. So we've been in operation about 16 months. As I mentioned, our focus is customer service, and our goal is to provide the best customer service experience in the industry. Second observatory is about half full, and we've got, I think, 5 more scopes coming in the next couple months. Not sure if we'll build a third observatory or not. It was difficult to build the first one. It was even more difficult to operate the first one while you're building the second one. It'll be even more difficult to operate 2 while we're building a third one. So just some comments. I would say personally, I can't stress how proud I am of what my family has accomplished out there. Everybody has pulled together, worked together. That there are disagreements about approaches and how to do things, but in the end, we've all worked together towards a common goal. And also, working with your adult children is something that I guess I didn't really anticipate how special that would be. To really get to know their work ethics and their skills and their knowledge, and working side by side with somebody for 1.5 years or 2 years, you get to know them in a whole lot different way than you do just over a Thanksgiving dinner every now and then. And I would say this is probably the most rewarding job I've ever had. So, are there any questions now?
Yeah, we have a few piling up. Did
Okay.
you mention, I think it looks like you're pretty close to being full when you bring in those other scopes, but what does it cost to rent a pier?
It starts at $800 a month, and that's for up to a 40-inch radius, which the CDK 17 on an L500 wedge mount is right at that 40-inch, or a CDK 12.5 on an equatorial mount would be right at about 40 inches. So, 40 inches is pretty generous, and then there's an additional charge per inch as you get larger than that.
Okay. One of the few questions. How sturdy is the Quonset hut? I think you kind of addressed that, but I assume you were perfectly comfortable with the conditions there and how sturdy that structure is.
Yeah, they are very sturdy, and once you get them bolted together, we were a little bit concerned about the building racking because we're pulling on just one side, and there is very little racking tendency, and if it does rack a little bit, it springs right back. So they're very solid. The larger building on Primrose, on the new building, is actually a little bit heavier steel, and that was recommended by Steel Master just because it was a little bit larger, a little bit bigger span.
Do you ever have any outages out there?
Um, Very rare. We've had one power outage that I can recall, and that was a planned service outage. So they told us a couple of days in advance it was going to be out for so many hours during the afternoon. We let everybody know. Most people have a little UPS at their pier to keep their telescope and their computer running until the generator comes on. And other than that, the generators automatically exercise every Tuesday morning or every other Tuesday morning. And that's about the only time they run.
Do you have cameras there for your customers to kind of log in and see what's going on?
We've got a few cameras on the website. Most customers put a little Wise camera or some sort of a little security camera on their pier somewhere. One guy has one mounted actually on top of the telescope, so he can kind of look at what the telescope's looking at. And that's one of the reasons we have the Wi-Fi hotspot.
And your customers are public, private?
Yep. Yeah, we've got government, institutions, private individuals, runs the gamut.
And the questions keep coming. Is there any seismic activity out there?
Not that we've ever noticed. The soil is pretty sandy. I don't know how well it would transmit vibrations, but we have not noticed any.
And I assume these projects have kept you young, Craig.
Yeah, there's a saying that young people tend to live in the future, middle-aged people tend to live in the present, and older people tend to live in the past. And this keeps me living in the probably in the present or future.
Okay. Someone asked what the cost of the observatories were.
Expensive.
You don't have to answer if you don't want, but I'm kind of curious.
The buildings themselves are around, I think they were around 15,000 each for the Quonset huts. And I tell people that that's probably 10 to 20% of your total cost.
Do I take it that who was a steel master? Do they
Steel master?
Yeah, they manufacture everything and put it in a pallet and send it out to you, right? So you can order a certain size hut or what?
Yeah, you can order a certain size Quonset hut, and you can order those channels from them. Everything else is of our own making. So, what they provide is this steel shell, and you can buy end caps from them. We didn't. And as an option, you can buy that C channel. And what that's intended for is you bolt the C channel down to a concrete slab and then erect your building on top of it. So that's what we bought from Steelmaster, was the shell and the C channel. And then everything else, rollers, rails, all that we had to design and fabricate.
Did you mention how you anchored the piers in that second building to the concrete floor?
No, I didn't. We do it with epoxy anchors that we drill into the concrete. So those usually go, I don't know, 7 inches down with the 1/2 inch or 5/8 inch all thread. And I will tell you, you can't pull them out. In Steve's industrial work experience before working here, they would use that kind of an anchoring system on big industrial equipment, and it had to be tested before they actually set the equipment. And 10, 20,000 pounds, you can't pull them out.
And so even after you got 300 pounds hanging off a wedge continuously for months, they don't move?
They don't move. Now, it's during the winter, they have a longer cure time. And that was a problem with the CDK-24 that we ran into. We had the bolt pattern for the pier, so we already had the anchors in and cured. And when the pier got there, it had a different hole pattern. So we had to cut off the anchors we put in and put in new anchors. Then we had to wait 24 hours for those to cure enough that we could set things.
How much time is spent doing mount maintenance, building maintenance, telescope maintenance, that kind of stuff?
It keeps the caretakers busy, but not busy full time. But there's something every day. They go up every morning and just walk through and look at the position of scopes, and are they parked in a safe position, or is anything making an odd noise? Walking through one time, for instance, a scope happened to be slewing, and it was making kind of a ticking sound as it was slewing. And it was an old Paramount ME style mount, and you can adjust the tension on the worm gear with those. So we tried adjusting it out, and we could make it better, but we couldn't get it out completely. So we contacted the owner and said, this is what we're hearing. It's running, but it's got a problem. Let's plan on the next full moon. We'll open it up and see what's going on. And it was a drive belt on the worm block that was starting to shred itself and was missing a couple teeth. So we were able to order belts and get that fixed and back up and running. But we're constantly on the lookout for things like that.
Alex, do you have a question?
Yeah, Isaac, I think it was, wanted to know, when you mentioned 40 inches, what does that mean? Does it mean how far the telescope swings around, or what? Yeah,
it's the telescope needs a 40-inch radius of clearance. And so usually if you, on an equatorial mount, if you, lay the telescope over on its side pointing north, and then measure from the center of the mount out to the far corner of the telescope, that would be the clearance radius.
So there's a circle of 80 inches from the center of the mount.
Yeah.
That belongs to that telescope.
Yeah. And most telescopes are going to fit in within that. I say an L600 with a CDK 20 or 24 is going to be a little bit bigger than that.
And so would pay more than $800 a month.
Yeah, the CDK 24 on an L mount with an equatorial wedge is $1,000 because of the additional radius.
Maybe this isn't our business because we haven't tried this, but I think it was Isaac asked, how do you go about determining the pricing structure for how much you're going to charge for a given size rig?
I don't know if there's a good answer for that. I mean, it's a combination of our cost and the market and the value that we think we provide. And then the additional cost is just, how much space it's consuming.
Okay. What about insurance? Who insures the thing?
We encourage everybody to have their own insurance for, for their equipment. And then obviously we have a lot of insurance for, if we happen to damage something or, that sort of liability. So we're well insured also.
Okay.
But we don't insure your telescope.
All right.
So there are a couple of combination questions. Someone asked about dust, and another question Tom asked about wind. I guess they'd be kind of related. So do you get dust accumulation inside the building when the wind blows?
We get a little bit, but not. I don't know if we get a whole lot more dust in the observatory than we do in the office. We've got brush seals all the way around the building. So there's brush seals all the way around the front and then all the way down the side and across the back. So it's sealed as well as we can. And it takes a pretty stout wind for you to feel anything blowing in. But we do occasionally get windstorms with 60-mile-an-hour gusts. And if you go over to the sidewall, you can feel a little bit of air coming in. But it's also open all night. So if there's any airborne dust that's settling at night, we can't really seal against that.
So that's what I was thinking. When the wind blows at night, even though it's clear, you can have dust fairly wall.
Yeah, that's pretty rare. Our typical weather pattern is it will be windy in the afternoon. And by windy, I mean, 20-mile-an-hour or so winds on our weather system. And we have to take that into account during construction because you're basically building a big sail. So, we have to plan it for a fairly calm weekend. But then at sunset, the wind just kind of dies down. And so you typically see 20-mile-an-hour winds all afternoon. And then at sunset, it dies down and it'll be calm all night.
Craig, you can stop sharing now if you
Okay.
if you want. We can watch you talk.
Okay.
I think we got them all, Eric.
Yeah, I think we do. And a few extras too.
Yeah, we had a lot of good questions tonight, so it was good to get all that interaction. And I love the level of detail you went into, especially for those of us who are planning on building an observatory at some point. Those little things to think about, like the floor joists and stuff, just like, oh yeah. All
So
kinds of stuff
how
you don't
close
know.
to being full up are you? You can't have too many open piers.
Like I say, the second building's about half full. I don't know if it's going to be full by the end of this year or middle of next year, but I would think, somewhere in there it's going to be full. So we have to decide. We know we're not going to build a third observatory this summer. As you saw, we spent the last 3 summers doing construction, and we all collectively said we want a summer with no construction.
Yeah.
But so if we do decide to build one, we would want to build it probably next summer. And that does give us a little bit of time. So, rather than having to do everything all at once, we could start, some of the soil prep and fabrication on the rails and so forth. We could spread that out all winter, so we don't have to do it all at once.
No rest for the weary.
No.
All right.
So now that you've settled on this and you can kind of sit back and go, oh, how do you feel about your initial decision to do this?
I think it was a good decision. Starting out, we thought this was going to be kind of a part-time job, and in reality has turned into a lifestyle. It's something that we work on and think about every day. There's just no getting away from it. But it has a lot of rewards. I say it's providing a great lifestyle for our kids. They love it out there. I tease them, it's kind of like being a lighthouse keeper. But I think everybody is real happy with it.
21st century lighthouse keeper.
Yeah.
Hey, I just had a question in my brain. What kind of science is going on out there? Do you know?
The Polish Space Agency is tracking the orbits of space junk, satellites and space junk, trying to maintain clear paths for space stations and other things. I know we've got one customer who focuses on exoplanet transits, and that really kind of blows my mind that someone with good backyard equipment can actually do light curves on exoplanet transits.
Yeah.
But probably most of it is pretty pictures.
Are there any more questions here in the room?
I don't know, not for me.
I think that's it from you two.
You're running the show, Molly.
I'm just seeing if y'all have any more questions.
I don't see any online.
All right.
Oh, we're good.
We
lots of,
actually kept our audience right to the end, I think.
Yeah, and lots of kudos coming in here as well. So yeah. All right. Well, thanks again, Craig. And that was really awesome. I really enjoyed that.
That was my pleasure.
I think everybody else really enjoyed that. And feel free to stay on after we end the live broadcast to chit chat. And I think with that, we'll say goodnight.
Good night.
Bye, everybody.
Good night, everyone. See you next week, hopefully.
Yeah. See you next week.